Sum to infinity. If r is less than -1 or r is greater than 1, the terms of a geometric sequence grow in size in absolute terms. That means ignoring negatives. Now let's just explain that. If a was 2 and r was 3, then the sequence would go 2, 6, 18, and so on. So we can see the terms are just getting bigger. If a is 2 and r is equal to -3, then we'd have 2, -6, 18, and so on. Now the terms are getting bigger if we ignore the negatives. So that's what I mean about absolute terms. This means the sums of these sequences will never converge. In this case, if we start adding up, the numbers just get bigger and bigger, and so the sums just get bigger and bigger very quickly. Here, we'd end up with a big positive, big negative, big positive, big negative, and it's not going to converge to a single value. It's just going to go up between being positive and negative all the time. On the other hand, if r is between -1 and 1, the terms will get smaller in absolute terms. And that's an easy one to think about. If a is 1 and r is 1/2, then we'd have 1, 1/2, 1/4, 1/8, and so on. So the terms are getting smaller, and it doesn't matter if this is negative, the terms will still be getting smaller in absolute terms, i.e. if we ignore the negatives. The terms of a sequence getting smaller does not guarantee convergence to a limiting value. For example, this sequence here, which is not geometric, it's known as the harmonic sequence, has terms that are clearly getting smaller. But if we keep adding more and more terms on, it just keeps getting bigger. It doesn't go to a limiting value. And the correct maths terminology for that is that it's unbounded. However, a geometric sequence for which r is between -1 and 1, these do have sums that converge to limiting values. Quite a nice way of explaining it is if you think about this as being the width of a room. If I ask you to walk halfway across the room, and then half of what's left, and then half of what's left, and half of what's left, and so on, you never actually reach the other side of the room. It becomes the limiting value. And clearly, if we go to 1/2 and 1/4 and 1/8 and so on, that is a geometric sequence. Now, consider the sum of n terms formula. S of n is a into r to the n minus 1 over r minus 1. If r is between -1 and 1, then as n tends to infinity, r to the n tends to 0. The sequences get smaller and smaller and smaller. This gives us s of infinity is -a over r minus 1. All we've done there is put the Rn equal to 0 in the formula because we know it will tend to 0. Multiplying top and bottom by -1 gives it rather more neatly as a over 1 minus r.